Hey everyone, Michael Unger here from the H.R. MacMillan Space Centre, located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. And I'm here in our cosmic courtyard. We are open. We have visitors here. This is going to be wild and live. And as always, for Ask an Astronomer, we have our astronomer just upstairs in her office, safe and sound, and that is Marley. Hey Marley, how's it going?
Hi, Michael. It's good. How is the Cosmic Courtyard? Are we busy?
It is. It does feel. It feels newish to be like around people again and having this bustle of activity. It's fun. This is the kind of energy that I remember from the Space Center. Walking to the gallery, seeing people. This is what it's all about. This is what our organization is all about. It's getting people excited about space and actually seeing physical people. Because for the past year or so, we've been doing a lot of online stuff. So over the next year, we're going to be continuing to do online stuff. We're going to be continuing to do our Ask an Astronomer on YouTube here. To all of you out there in YouTube land, also in Telus Optic, where every second Thursday we're going to still do this, but we're also going to be doing in-person stuff. So this is a really exciting new time that we can now move into 2021, 2022. How are you feeling about it, Marley?
Good. I am excited to start meeting people because I started doing mostly online and I've slowly been doing some brief, very brief in-person things. So I'm excited to get more into the hybrid and bring back the in-person thing a bit.
Awesome. So, for everyone out there watching, today's theme, as you've been watching the news, there's a couple of really exciting things that have been happening over the news. I was live on CBC, Marley, talking about Richard Branson going up into space with Virgin Galactic. Now, there was a really intriguing question that came up during that flight, if you will, and that was, where exactly is space? Did Richard Branson actually go into space? So that is our theme of our question today. But of course, if you are out there watching and if you have any questions about space or this question, put it into the YouTube chat. We are here with Marley. Marley will answer all of your questions. But we're going to start with this big one because it's interesting. Because if you actually think about that question, where does space begin? Where does the Earth end? Where does space begin? It seems like sort of an esoteric question, Marley, but there actually is something very interesting once we dig in deeper, because it has a lot of ramifications for things like buying a ticket, a very
Yeah.
expensive ticket to go into space, but also some legal ramifications. So, Marley, where is space?
The question of today, where is space? So some background, Virgin Galactic had their successful test flight on July 11th with a full crew, and they reached an altitude of 86 kilometers and they experienced about 5 minutes in weightlessness. So the image shows Richard Branson, a photo of him from a image from a video, and the bottom shows Richard Branson, Beth Moses, and Shrisha Bandla in Unity 22 experiencing weightlessness. And they look like they're having a great time. But their time there was kind of, marred by this question of did they even go to space? So there are two types of space flights that we talk about a lot, especially right now with all the space travel going on. We have suborbital and orbital space flights. So a suborbital flight will cross the boundary to go into space, whatever that boundary may be, but it will not stay there. It will fall back to Earth. Orbital flights will remain in space for at least one orbit or one full rotation around the object it's orbiting. So, for example, on this diagram, this is the cannonball diagram that's really popular. I saw it in my physics classes. Objects A and B, if they cross the threshold, would be considered suborbital flights. They crossed the boundary and they did not stay, they fell back to Earth. Whereas objects C and D would be considered orbital if they completed a full rotation around the Earth. So the Virgin Galactic flight on July 11th was a suborbital flight. It started with there's Spaceship 2 and White Knight 2, who were named Unity 22, and I think Mothership Eve was the name of the White Knight 2. And so the plane brought it up to a certain altitude, and then they separate. So the smaller Unity 22 comes off of the mothership and starts its vertical ascent higher up into space. And then it reaches a maximum altitude, and the passengers experience microgravity. And then it moves its apparatus on the ends, the two booms, into a specific position, and it starts its re-entry back to Earth. So it glides back down to the landing station. So it's a really cool flight, really awesome orbital flight, but there was a lot of discussion about whether or not they actually reached space. So lots of headlines. Will Richard Branson actually reach space on the first fully crewed launch? Where does space begin? And then a remark from the Blue Origin CEO, Bob Smith, who they're supposed to be having their first launch on July 20th. They've been go for launch at about 6 a.m. Vancouver time. Who said, "We wish him, Richard Branson, a great and safe flight, but they're not flying above the Kármán line, and it's a very different experience." He said that to the New York Times about Richard Branson's flight. So really, what he's saying here, Bob Smith, is like he's not technically going to space. That we will be technically going to space, but Richard Branson, if you watched the coverage, all of the crew on the flight got their astronaut wings. So what's the deal with that? So there are 5 layers to Earth's atmosphere. And a really common thought is, oh, well, space starts when Earth's atmosphere begins. But it's not as simple as that. So there's 5 main layers to Earth's atmosphere. We've got the troposphere, close where we see all the clouds and the weather. The stratosphere, which is the layer of ozone that absorbs the UV rays. Sometimes commercial jets will fly in the lower part of this to avoid turbulence, because the turbulence and where most commercial jets fly are in the troposphere. The mesosphere are where meteors and the shooting stars happen, and it's the highest elevation where a cloud can form. The thermosphere is where the Kármán line is. So the Kármán line is at 100 kilometers above sea level, and that is located in the layer of the thermosphere. It's where energy, UV and X-ray radiation start to be absorbed, and it's highly dependent on solar activity. This layer is also where the International Space Station is and where auroras tend to form. It's also in the thermosphere where Earth starts to be distinctively curved and where space travels feel the weightlessness. And the exosphere is the final layer. And it's not like a harsh stop at 600 plus kilometers. It's actually like a gradual going into outer space. And this is where a large amount of low Earth orbiting satellites occur. So the International Space Station orbits at about 386 kilometers. But you can't, if we were go with the 80 kilometers that the Unity 22 crew passed, which is what the United States considers to be space, then the International Space Station is in space. But if we consider, where the atmosphere ends is space, then the International Space Station is not in space, even though it's in the name. It should be. So a lot of the problems start with satellite orbits. When you take this definition of, it's where the atmosphere ends is when space begins, because there's no single altitude where a satellite can stay in a stable orbit. Where what we consider space will depend on the type of satellite and the orbital trajectory of that satellite. And there's lots of different orbits for satellites. There's all of these kinds of orbits. So one of the main ones that we use a lot is a low Earth orbit. And this low Earth orbit, as it suggests, is close to Earth's surface. And these satellites are normally at an altitude less than 1,000 kilometers, but they could be as low as 160 kilometers above Earth. So the International Space Station would be in a low Earth orbit. MEO, or a middle Earth orbit, is a very wide range, and they don't need to take specific path around the Earth. And these are usually navigation satellites. Geostationary orbits circle Earth above the equator from west to east, following Earth's rotation. They look stationary over a fixed position, and they go about 3 kilometers a second at an altitude of 35,786 kilometers. So they're much, much further from the Earth's surface. So if we were to say, that atmosphere ends at 600 kilometers, the geostationary satellites would be in space, but some low Earth satellites would not be in space, which doesn't make any sense. If it's orbiting us, isn't it in space? It's further complicated by polar orbits and sun-synchronous orbits, because these are both types of low Earth orbits. Polar orbits go north to south over the poles, and a sun-synchronous orbit are a type of polar orbit, but they are synced with the sun. So it would be like they have the same fixed position. They're in the same spot at the same time. So if the satellite passed over Vancouver at noon exactly every day, it would be a sun synchronous orbit. And these usually are about 600 to 800 kilometers, and they can move at about 7.5 kilometers a second. So we have all these different types of satellites, and we consider them all to be in space, but it's complicated again with different transfer orbits. So this is a geostationary transfer orbit. So if we start in a lower Earth orbit, but we want to go to a geostationary orbit, we would do this fun little transfer orbit. So a satellite could start not being in space, but then end up in space, which doesn't make a ton of sense when you start to think about it. And then we have the case of elliptical versus circular orbits. So a circular orbit, you have the same distance around the Earth the entire way around the orbit. So a satellite would always be in space, or it would either not always be in space. For elliptical orbits, it changes. The distance the satellite is from Earth changes. So how far away it is, or the apogee, may be in what we would consider space if it passes, say, 100 kilometers. But then during its perigee, or how close it gets to Earth, would not be in space. So we have all these different ideas of what it could be. And a astrophysicist named Jonathan McDowell actually published an article finding that a better boundary to consider where space may be would be that 80-kilometer mark that NASA considers. And he used another physicist, a historical physicist, Kármán, his math with data from modern day orbiting satellites. So what McDowell did is that he looked at a database with 90 million orbital paths from these satellites over 60 years of spaceflight, and he looked for the lowest approaches that had multiple orbits. So how low in the atmosphere a satellite could be and it still maintain an orbit. So for circular orbits, the lowest value was about 120 kilometers. For an elliptical orbit, it was about 80. So either 80 kilometers should be considered space, or they're in orbit, but not always in space when they're in orbit, which is just a silly thing. So where space begins, these are all of like some of the official values I could find. So the FAI considers space to officially begin at 100 kilometers or 62 miles. And the FAI is the governing body for aeronautic and astronautic records. So in theory, at 100 kilometers, once you cross this boundary, the atmosphere becomes too thin to provide enough lift for conventional aircraft to maintain flight. So up here at 100 kilometers, you would need to reach orbital velocity, the velocity you would need to be able to orbit the Earth, or you risk falling back down. The Kármán line, the Hungarian physicists determined this value to be about 80 kilometers. In reality, the range was 70 to 90 above sea level. But today we use the value 100 kilometers, and it's not totally clear why. Some argue that it's because 100 is just a nicer number to use, and it is. But some argue that there's actual mathematic basis for that number, but I was not able to find any. The Federal Aviation Administration, the US Air Force, NASA all use 80 kilometers. And they use this because it was set through the testing of the X-15. So this aircraft was designed for control in both the atmosphere and in outer space. And at 80 kilometers is when the aircraft switched its controls from aerodynamic propulsion to atmospheric propulsion. So it started using different physics to fly itself once it hit 80 kilometers. NASA Mission Control, though, uses 122 kilometers for this, for its where space begins line. And they use it as a point of re-entry, and because it's where atmospheric drag becomes noticeable. So it's very confusing as to why these different groups use different lines. I find it very funny that NASA has two different values it will use depending on what's going on. But it causes a lot of problems for it. And especially with the increase in space tourism, quote unquote, it starts to become a larger problem of where actually space is. And most experts will consider when space starts is when orbital dynamics become more important than aerodynamics. So where the atmosphere is not enough to support a flying vessel at suborbital speeds, but there's no exact value for that. But because it depends on what type of orbit you're trying to maintain, will depend on what speed you're on and how heavy the thing you're trying to launch out of Earth's gravity is going to be. That will impact the amount of fuel you will need. It'll impact the trajectory that will be most optimal, which will impact the orbit. There's too many variables to try to give an exact value just based on that.
Right. And I guess like we're going to stick on this topic for just a few more minutes, Marley. We do have another topic, but for everyone out there watching, you might be wondering like, why is this, so important? Of course, it's important for different people, of course, for the space tourism industry, it does sort of become important for regulation purposes. It's also important. I can sort of see why NASA Mission Control might have a different variable because they're specifically thinking about astronauts re-entering the atmosphere. But my question for everyone out there watching on YouTube, I'm curious, if you were a space tourist, what would you consider to be space? What would be the important factors for you to consider where space is? Marley, what do you think? If you were going to go out into space, what are some things that would make it space for you?
Probably experiencing weightlessness or
Yeah.
microgravity is like a big one. Like that's the big one. And I would like to see the curvature of the earth. That is something that's very difficult to see. I know there are some, like if you build a very tall building, you can kind of see it, but I want to see the full like spherical shape like of the earth. So take me to the
Yeah.
International Space Station. I think that's like been in my brain. I'm like, that's when real space starts, even though it's really not.
Right. Well, I mean, but there's a difference there because the International Space Station is a little bit further, and where Virgin Galactic is going is more on that 80 kilometer. Actually, no, yeah, the 80 kilometer mark, right? So it's actually a little bit less than a little bit. No, it was around there.
They
Virgin
hit
Galactic.
86. So yeah, it was about 80 kilometers. Yeah.
Well, there you go. And yeah, so if you're going to experience space, what does it really mean? Well, yeah, weightlessness, that thing that we classically see, and then of course seeing that curvature of Earth. For me, if I was spending that much money, that's what I'd want to see. Of course, maybe a little bit longer of a time period up there. I think eventually, as they get better at these orbits, they'll definitely do that. But it is interesting seeing these two companies that are vying for the space tourism industry. Marty, if you were given a free ticket, would you go? Would you go on either Blue Origin or um, Virgin Galactic?
I don't know. I have like a deep fear of like things exploding. So like the like even planes make me a little nervous, but I would love to see it. I just maybe a few more test flights and then give me a
Okay.
free ticket. Yeah.
Anyone out there watching on YouTube, put into the comments, would you like to go on a Virgin Galactic or Blue Origin flight if you were given a free ticket? There's a contest actually right now through Virgin Galactic if you wanted to win a free ticket. But yeah, did you have anything more on where space begins and where Earth ends, Marley?
I did. I had more about these definitions. So I read this really awesome paper by Bhavya Lal and Emily Nightingale that was entitled "Where is Space and Why Does That Matter?" Which is a really great paper from about 2014 from the Space Management Conference that really got into this very question that we're asking today. So currently, we don't really have a definition from where space begins, but we have said that space is free for exploration and for use by all. But airspace is specific laws to each country. So where if we were to make a definition for space, that would mean we had a boundary where space law had to begin to apply and all of the legal implications for that. So the arguments against that were highlighted in this paper was that it might be impossible to create one just because of all the different values and narrowing down different orbit types and things like that. There's just so many variables that can influence if you are in quote unquote space. And another argument against was that it hasn't caused any problems yet. In all of the time of space travel, this hasn't really been a problem before. But I don't think that last one's a particular compelling argument because we weren't doing space flights for the public before. And so the arguments for are about know how high sovereignty goes. So each country, each sovereign nation has its own airspace, and it becomes important to know how far up that goes. And if you start impeding on another nation's airspace, like when I travel from Canada to United States and I fly through US airspace, I have to go through US customs and follow their rules. And would the same thing apply to space travel? If you did a suborbital flight from Canada to across into England, would you have to go through custom? It becomes a big question there. And also space traffic, increasing space traffic. Lots of different countries have expanded their space programs in the past decade or so. And so increased participation means increased traffic, which may mean more rules in terms of landing and launching, because currently we are not obligated to notify another country if we are landing something or launching something. That's why there was a lot of surprise when the rocket launched by the Chinese fell back down after it didn't make it. It fell into a suborbital trajectory and landed back on Earth. Legally, we don't have to notify if that's going to happen. It's nice to do, but it's not an obligation. And so does that become an obligation because you've left the space boundary and now you're falling into airspace boundary? And especially with traffic, with reusable vehicles, space traffic goes up and becomes more common because you don't have to build a whole new rocket each time you launch. So especially when they cross into suborbital flights, when you experience that 5 or so minutes of weightlessness and then come back down into airspace, are they considered air vehicles or space vehicles? And which laws govern which? And there's also the concept of innocent passage, which is a maritime concept which grants foreign nations access to territorial waters when the vessel is peaceful. So this innocent passage would apply to when re-entry. Like, I'm just going to fly through your airspace real quick. I'm doing a peaceful mission. We're just landing people again. But are we going to enable laws surrounding that and legislation surrounding that? So there's arguments for and against, and it's still a debated topic today. And I only anticipate that it's going to become more involved as these launches continue.
Right.
And this was the last big story.
Exactly. So Marley, so that was our big story of the week, was Virgin Galactic going up into space. But the other thing that came up the other day, this actually came up in my Twitter feed, and it was like, it sort of caught me off guard, and I was like, what? Wobbling moon will cause devastation worldwide. A very sensational headline, but I did see a lot of chatter about it overnight and even into this morning. So I thought, for any of you out there, if you have seen this headline, Marley, what is going on? Why is the moon wobbling, and why are we worried about devastating floods?
Yeah, so the moon has always wobbled. This isn't new. It has a wobble that takes about 18.6 years to complete, like kind of like a top spinning as it slows down. Same thing happens with the moon. The wobble's not new. We've been aware of it since about like mid 1700s, 1728, I think, is the year. And we've known about it for a really long time. We're actually currently in the high cycle right now, the amplification cycle right now. And sea levels haven't risen very much, and high tides haven't been topping the flooding thresholds like regularly. So, but the big problem is with next time in this 2030 year. So there will be an increase in high tide floods, which the study that NASA did focuses on the U.S. coast, but it will probably extrapolate to all coastal cities. And it's not just due to the moon's wobble. It's actually has a lot to do with the rising sea levels that have been going on. So with more ice melt and the global ocean level rising, there's more water to be affected by the moon's gravitational pull. So in half of this 18.6 cycle, the regular daily tides are suppressed. So that means the high tides are lower than normal and the low tides are higher than normal. So the moon's gravity pulls, like if you think about it, in the opposite direction of whatever the tide will be. In the other half of the cycle, where they're worried about this in this 2030s time range, is the high tides will be higher and the low tides are going to be lower. So it's going to amplify whatever is already happening. So with global sea level rise, the tides will only get higher. So when the moon enters the next amplification phase, it'll make whatever's there even more. And so it'll just increase the effect of the higher sea levels that we will have. They think that the big problem is that we're not seeing it as much now, but in another 10 or so years, the global sea rise will have gone on for another decade, which is their big concern there. So the higher seas amplified by the lunar cycle will cause a jump in floodwaters on the US mainland coastlines, Hawaii, and Guam. Far north in Alaska will be spared from this for another few decades or so, because the land areas in that region are actually rising due to long-term geological processes that aren't like human impacted. It's just the Earth doing its thing. But the global sea level rise is due to us. So what it will look like, it won't look like a massive flood. Usually high tide floods aren't really considered a problem as much as like a hurricane flood, because it sounds like a smaller amount of water. But what this is that it'll look like multiple flooding events over days. So 10 or 15 times a month, when there's a high tide and it's amplified, you will get a flood. And this will become a problem. Like stagnant water poses public health issues. People can't get to work. If there's reoccurring flooding in one area for very long, businesses may have to close, water damage or parking lots flooding out and things like that. So that's the concern. Devastating, yes, but it's not like the moon is all of a sudden just flopping back and forth. This is like something we're aware of. And what's really the problem is how much the ocean levels have risen and how much the global levels will continue to rise, and how the lunar cycle will affect them.
Yeah, it sort of seems to me that these headlines perhaps should be rewritten to kind of put, instead of putting wobbling moon as sort of the main cause of this, it should be really human caused climate change as the front. And it's like, well, and the moon, which does cause the tides, is going through this phase that will be exasperated by the human caused climate change.
Yeah. So what will already be bad is just going to be exasperated by the moon. The moon is just doing its thing though. So
Yeah.
it's not, yeah.
Absolutely, the moon is doing its thing, and if you're out there, the moon actually looks fantastic tonight, or last night, Marley. I don't know if you were out looking up at the skies. It's just in a quarter phase right now. Certainly, is there anything else up there in the skies that people can go out and look for? Here in Vancouver, in the Lower Mainland, we certainly have some very clear weather.
Yeah.
The sun, haven't had rain in a long time, so lots of good stargazing. What should people be on the lookout for?
I'm always gonna be on the lookout for Jupiter and Saturn in the early mornings. I love those too. Like they've started moving further apart after the conjunction, but I love seeing them always. And of course, Venus, I think, is still up in the evening. Right now, if you go out, I think it should still be. Mars is technically up, but Venus is very bright, so it's hard to see Mars right now. Venus outshines its cousin there, but keep an eye out for those as well.
Awesome. So get out there, go out and look for those objects high in the nighttime sky. And for all of you on YouTube land, we only got a few more minutes left. If you have a question to get in for Marley on either of the topics, where is space, what's up with the wobbling moon and the high tides, get them in. Marley, next month, here at the Space Center and of course up in the skies, we are going to be really focusing in on a really big event, probably the big celestial event of the summer, and that is the Perseid meteor shower. We're going to be doing a live in-person event, actually in the backyard in our park, where we'll use the natural planetarium. So that's going to be on August the 12th. Marley is going to be out there, and also we're going to do a live online event. So that's really cool. What are you looking forward to with the Perseid meteor shower event, Marley?
I'm hoping that it'll be clear because the past couple times I've tried to see them, it's been cloudy. So I'm really holding out for clear weather for this time.
Absolutely. So if you're in a spot and you want a primer, and if you're outside of the Lower Mainland, you should join us on the 11th, which is the Wednesday, because we're going to do a live stream and we're going to talk about the Perseids. We're going to bring in some special guests. I even today actually secured an eye scientist, and the eye scientist is going to actually join us and talk to us about what's happening with our eyes when we're dark adapting. I've always wondered about this. Marley and I usually talk about this often when we're giving people tips. You want to get away from the bright lights, you want to get outside and make it dark so that your eyes adapt, so that you can see more stars, you can see more of those shooting stars, right, Marley?
Yeah, like that's one of the big reasons why you don't want to look at your phone with, especially if you're dark night gazing, dark sky gazing, or you want to put like a red filter over your phone as well. I've known that helps quite a bit. The blue light that it's harder for your eyes to adjust from blue back to dark, easier to go from red back to dark. I'm
Yeah.
interested in what that the eye scientist is going to say. I
Well,
wonder
you know
if
what,
they have more tips.
well, if you want to find out what Marley is going to ask the eye scientist, you should definitely join us on the evening of the 11th. That's going to be really fun. I'm going to be going camping actually next week, so I'm hoping for some clear skies. I'm hoping to keep my eyes dark adapted. Good tips for all of you that are out there. If you're going out there camping, this is going to be a great season for stargazing. Hopefully, you see lots of beautiful objects, moon, stars, planets, meteors, and think about all of these questions about where is space and that wobbling moon. Thank you so much for joining us on another edition of Ask an Astronomer. We will be back in 2 weeks to for another edition of Ask an Astronomer. Of course, if you have any questions, you can send them to Marley. She's got our email up there, astronomer@spacecenter.ca. And you can also send us questions if you want a future episode. If you want us to answer some of those questions, we'll answer those too. For me in the Cosmic Courtyard, just closing up shop here for the day. Of course, if you'd like to join us here, you can go online and book your ticket. But until next time, take care, everyone.
Bye. See you in 2 weeks.